Okay, from the basic concept in designing the heat exchanger, which is this design will be focused more on the heat shell and tube heat exchanger. Okay, the log mean temperature is one of the main properties that we should calculate before we can proceed to the surface area required in heat exchanger. Okay, the mean temperature difference or temperature driving force can be calculated when we already define what is the hot inlet temperature, hot outlet temperature, cool inlet and cool outlet temperature that give you the true mean temperature from the log mean temperature that we need to consider the temperature correction factor. Okay, there are two ways to determine the temperature correction factor using this equation, which you need to define the value of Rs. Okay, Rs is the dimensionless temperature ratio based on the outlet inlet for cold and hot fluid using this equation. And finally, you can obtain the correction factor, or you may refer to the diagram here. But to obtain the value of F here from this diagram, you should already define what are the type of the shell and tube passes. Example, if we have one shell, okay, this is the shell area, and two or more even tube passes here. So once you obtain the value of S and also the R here, basically you just drag example here and then the drag to give the value of FT. Same goes to another design. If we have two shell passes, so you can see here we have one and also another. This is the baffle, and we have another shell passes. So basically it gives us the 4 or multiple tube passes. You can obtain another value of FT. This is based on the design of divided flow shell. So you can see here we have divided flow shell, two inlet, and we have another outlet. So basically we have the focus more on the shell. So it gives us the value of FT from the calculated value of S and also R. This is for the split flow shell. So you can see there are split for the shell here, and we have two passes too. So to determine the correction factor, you can either use the equation or you can define from this diagram. And then next we will move to the tube and also shell side heat transfer coefficient, including the pressure drop.